At least for me, it's not yet there. Okay, it's coming. Yeah, it's your screen is visible now.
Okay.
So yeah, hi everyone, and thank you for joining today's session. On the day two of AI Study Jam, we have our speaker Vibhor, who is a machine learning engineer, and he'll be helping us better understand the basics of machine learning. And yeah, we'll have a next 2 hours of learning on machine learning introduction. And before we get into the session, there is a couple of things that I wanted to share, and which is um, the recording, which is going to be available in our YouTube channel. Please do make sure you watch it if you missed any part of the recording or any part of the meeting. And secondly, there is certificate of participation. In order to get there, you need to have the 4 days of attendance. You need to fill out the attendance form, which I share at the end of the session, which I shared in the chat box. And if you're not able to see the chat box, you can personally reach out to me on the community, and I'll be able to share it to you. So we'll have 4 days of attendance, and after that, you will have a certificate to your email once you fill out all the days. So yeah, that's all of the things that I wanted to share, and I hope you guys will have a great 2 hours of learning on machine learning. And with that, I'm done here and moving to Vibor, and he'll be taking over. Over to you.
Thank you. Okay. So, just in comments, if people can tell, like, how many of you have tried building machine learning models before this? Mm, seems like not a lot, or do people need some time? Okay, there are some people. Okay, so a completely fresh batch, right? Okay, cool. Okay, let's start. Okay, so machine learning engineering is like any other engineering, like software in life cycle. Machine learning has a machine learning life cycle. This is a small representation. It's one of the most famous life cycles, which was popularized in one of the research papers. Uh, Overall, it has like four main layers. One is the scoping layer, where all the project managers and all the clients will get together and try to define the project. If you're doing a personal project, say face detection or like a burglar alarm, you'll set certain parameters, like how secure it has to be. uh, is false is a false alarm uh, okay, like how often it should happen, or what if a burglary happens and the alarm doesn't go off. All these sorts of consequences, and based on that, certain parameters which you define during this process. The second part is data. And data collection is one of the most like controversial topics right now, because like there's a lot of talk like data is the new oil. A lot of companies try to gather data without the customer's consent, and like there's a lot of data available online as well, through certain uh, open portals, right? Which we can use for our machine learning models. But in general, like there's a lot of controversy uh, around who owns the data, and there are a lot of new laws coming up, right? And the second difficulty with data is how clean it is. And by clean, I mean how usable it is for the program that you have written. That is another field that is coming up, like data mining and data visualization, data exploration, data cleaning. This is primarily what a data analyst might do. but it is one of the most important points if you have to build a model, because if you are building a model and say in the final stage you realize, okay, I need a certain level of data that is not available, you'll have to go back to the first step and create that data and run the whole pipeline again. So messing up in this part can uh, lead to lots of long iterations, which we will in general try to avoid. And obviously labeling and organization is another difficulty. In past years a lot of companies have come up with their own solutions, like TensorFlow has come up with TF records, and a lot of talk around compression because
Vibhor, I'm sorry to
sorry.
interrupt the presentation, but I think the presentation is not visible. It shows a click to exit the full screen. Okay, now it's visible. Yeah.
Is it visible like this? uh,
Like it's a presentation open and you can see
Let me
presentation.
reshare. Let me reshare. Allow to Is it visible now?
Yeah, it is visible now, but it's not in full screen, but I think it
It's
works.
in full screen in my
Yeah, it's in full
it's
screen now.
right. Yeah, cool. Thanks for pointing out. Okay, so this is the cycle I was talking about: scoping, data, modeling, and deployment. Scoping is where all the project managers come into play. Data is the one that we were discussing right now, like labeling, organizing the data, collecting the data, cleaning the data, all those steps. Uh, yeah, and I was talking about the different visualizations and data cleaning processes, which we will discuss in a little detail in a while. Then there is the modeling part. There are certain uh, there are certain algorithms that don't require a lot of compute. You might have heard in the news, like the data set is like a few billion lines or something, or like a few terabytes or petabytes of data. So that is why it's called big data, because the amount of data that we are getting is humongous, and it keeps getting bigger because we keep finding new matrices to record. Like earlier you might be recording, say, the heart rate of a person. Now with all the new smartwatches, you can also measure the oxygen levels. So there is, that's like a new metric to record, and it's happening per second. So, and for thousands and millions of users potentially. So you can imagine the amount of data that it generates, right? So aggregating the data and uh, like making it feasible for using in the modeling stage is what you do in the data stage. And uh, like messing it up can lead to, like, it can lead to multiple iterations, like I said. And then you go to the model stage. Then there are certain models that don't require a lot of compute. Like you might have heard of regression, you might have heard of random forest. And then there are certain models which require a lot of compute, and the most famous example is the chat gpt model, right? And if you are following Google, then the palm model or the BERT model, that they are the palm model basically, which they have used to train the bard AI, which is the competitor of chat gpt, right? So these huge models require a lot of compute, they require a lot of gpus. And there are a lot of services available like AWS and Google Cloud and Microsoft Azure that provide that provide all these computes for a certain price that you can try to explore. But if you want to do it on your own laptop, then there are certain restraints. So I'll train one model and show it to you, and I'll show you how you can like leverage the online resources to train your own models. But at least for this presentation, we'll not go into the details of how those models work and how those calculations happen. We'll keep that for the next session, where I'll go into all the mathematics and how each and every calculation is being made, but I'll give you an overview anyway. The last part, which right now is catching up, is the deployment part, which involves deploying the model. Now, deploying the model might seem like a very inconsequential thing, but when you have a very large model, or when you want to service, when you have a product that requires a response within seconds, like within 1 second, say, you need to have a very uh, high performant system. And for that, people got into the deployment part. They started researching how you can compress your model, like you compress any other file, to so that it gives good performance. Now, com- with compressing the model, there is an issue that you might lose some of the accuracy, which can be a big issue in certain industries. Like, say, if you have a IAI software for doctors, you want it to be as accurate as possible, right? And it is time it's time consequential, so you want it to respond as soon as possible, right? So that is another challenge, and that is why, like, people started researching into this area. And another issue is that the data might change because human behavior changes, right? Like, a basic example is how user spending changed after COVID. Like, before COVID, there was a certain pattern. During COVID, there was a certain peak, and after that, there was a different pattern of how people behaved in general, and that affected all the industries. And because it affected how people started treating money, right, and how they started purchasing, and that is the end goal for most of the commercial AIs. Research AIs like ChatGPT are a little different, but still, in incorporating these basics into your engineering would obviously help you, like monitoring how the patterns change and retraining your model based on those changed patterns, and defining, like, when can you say that, okay, a particular pattern has changed. So these are all the uh, hot topics in hot topics discussed while you deploy the models, right? So this is a typical overview, and we'll dive into the data part, and then for now. So I was talking about different data sets, right? So when you start your project, you will find some very common data set. MNIST is one of the most common ones. Like, a few years ago, all the tutorials, all the projects were on MNIST, and MNIST is basically handwritten words, and people were trying to train models to make computer recognize handwritten letters, which then expanded into hand letter words, which then expanded into OCR, or optical character recognition, which basically means that you can give it any document and it will convert it into uh, text. Now, there was a certain algorithm that would convert it before MNIST as well, but that was restricted to scanned documents. Like, it had all the font, and it had a fixed pattern. But with with handwritten words and with humans in the mix, it gets a little more tricky. As you can see from the example here, uh, all these letters uh, are the same but not so similar. So a computer algorithm might find it very difficult to find patterns in it. So people started training their AI models on this model, and you'll find a lot of examples online. The second most the common data set is the Titanic data set. It basically has, like, how many people survived the Titanic crash, and what was their age, gender, and all that common info. Titanic Iris, Boston House sale price, IMDb. These are the most common ones. IMDb is the most common one you'll find when you are training something on a text, because it has all the reviews for all the movies and certain genre and all sorts of things. So if you are doing an NLP project or like a natural language understanding project, and you are going through the basics, I this will be the one you'll find tutorials for that one as well. Now, some of the more interesting ones available online that you can do and that can potentially lead to a good uh, project is like stock market data. It is freely available. A lot of stock exchanges have started sharing APIs so that people can pull their data and start training their models. It might, in certain cases it might cost you, but certain APIs are freely available, and certain stock prices tables are also freely available, right? And so you can go there, train your model, try to predict the market. Obviously, it's interesting because you can start small, but there is no limit. You can go and you can research as much as you want, because it will give you good results, but it won't give you uh, good enough results so that you can start applying it in the stock market. So you can try it, but like, don't bet your money on it till you get a certain level of proficiency. And obviously all the big stock market giants are already using certain ML principles to predict their models. It got converted into a different field of its own, but all these algorithms, all these basics were there long before, and people were using it without giving it a formal name. The second most interesting uh, topic that you can research on is fraud, or you can say credit card fraud, online transaction fraud. This like, you can even get, if you do well enough, you can even uh, apply for a job in a bank or some cybersecurity company. You can It's a very good project to showcase if you do a lot of research and refine your models. And COVID data or healthcare data is another freely available data. Like during the pandemic, a lot of countries started publishing their data online for freely for others to like look into it, so that because they wanted as many people to research on it as possible. So now you have a certain government websites that provide data to the public without any charge. So you can just go to the government websites, you can look what type of data is being given out. Obviously it will be very messy. Data cleaning is a big issue with the government websites, and all these examples uh, we will be using will be clean data. So what type of data should you use and where to get it? So where to get it? Kaggle has become one of the biggest data set repositories. You can just go to Kaggle. I can share the link, and like, you can screenshot it or whatever. You can just go to this link and you can check thousands and thousands of data sets that are freely available. It will include stock market data. It will include certain images like rice and everything. And what type of data do you want? Like, there are tables, there are images, and there are texts. So stock market data is obviously a tabular data. If you want to do something like face recognition or handwritten words, you will use images, which is like unstructured. And I'll tell you why we categorize it in unstructured in a minute. And then there is text data. So text is freely available uh, everywhere. You can just scrap a website, you'll get a lot of text, and you can then start training it. Like, after after chat gpt came in, a lot of people started training it on their own data. Like, law firms started training it on law related data specifically, and started specializing it. So the type of text that you collect is also important. And uh, the cleaning the text part is also a little tricky, because there are certain like there are certain words which might have a dot at the end of them, like, because it's the end of the sentence, but that dot is inconsequential in what that word is. Certain words might be capitalized, but you don't want capitalized words to be treated differently from small case words, right? So all the that cleaning part also comes into play. GitHub is also a good place to look for data sets. There is this awesome public data set repository which will point you to all the publicly available data. Most of the clean data available right now is from universities, which is basically used for their own research. But they have published it for to support, basically, so that they can support their research, or they can help other people expand on their research. But yeah, most of the freely data available right now is from universities. So we'll look into images. So one of the major issues with images is first there might be images from different mobiles, right? And that might affect the quality of the image. And then there are different resolutions, like one image might be 800 cross 800, another might be 1500 cross 1500, right? And then there is within the image there is lighting, there is obstruction. Like you can see here, one rice grain is obstructing the other rice grain, so you can't get a full image, right? There might be occlusion, like if the background is also white, it might it might become very difficult to detect all these rice grains. Like this is a complete mess, right? So you can imagine all sorts of problems you can have if you want to get a single rice grain. This, on the other hand, is a sorted view of all the rice grains. Now you can take them and you can train them on your model, and you can basically create a model that, one, differentiates between different types of rices. Two, checks for any visual defects, like whether it has any mold on it, or if it has any chalkiness in it, and other types of defects that are there in rice. And then basically you can create those models, and these models can help in agriculture industry to scan for different defects. Like you can install it in your warehouse and like scan for rice once a day to see the condition of the rice. Or while the rice comes in, you can just put in a camera and scan the rice to make sure that whatever you are getting is of good quality. There are a lot of applications in agri-tech industry for these kinds of models, although it's still research and there are no commercial companies that are doing this right now. But it has a good scope, and it basically gives you a good overview of what a unclean data and a clean data set might look like, and why you might prefer sites like Kaggle to and different university data sets over publicly available raw data like Google Images, or like something that the government might give, because it can have inconsistencies, right? uh, okay, now talking a little bit about data cleaning in general. Like there is text, there is images, and then there is tabular data. Now within tabular data also, there is no surety that it is clean even if it is tabular, right? There might certain issues might be that you have a column that says whether like a person enrolled in a certain program or not. You can, and for that you can have y, you can have n as entries, but somewhere down the line some users might write yes, right? And a software might treat it as a new entry instead of y, right? So fixing all those issues becomes a part of the process. And then there are like certain structural issues. Say you have a data set for housing prices, and it has length, width, and area. Now you can either keep the area column or you can remove it, because you already have length and like if you are keeping area, you can remove length and width, because the collection of these three columns introduces redundancy into the table, right? So these kind of decision so these are the kind of uh, cleaning you might get into initially, and then you start checking into the different column values. And there might be some blank spaces. Okay, the area is not available, and if area is one of the if is an important factor in your prediction for house prices, like then you can just ignore all those values where area is missing. Now how would you know it is important? There are certain uh, analytical techniques that you can employ for Tableau data to see if whatever you're trying to predict responds to the particular column or not. One of the most basic algorithms is the correlation part. So you can get it even on MS Excel. Basically, one denotes that it is highly correlated, and if you increase the value of one column, the value of the other column will increase. Minus one denotes the opposite. If you increase the value of one column, the value of the value of another column will decrease. Right. So that way you can find relations within the table. Then there are certain outliers. So for those who are hearing this term for the first time, outliers are basically uh, extraordinary entries. They might be on the positive end or they might be on the negative end. Say for height, or like the average height you might say is 5'6", right? So what might be an outlier? Someone who is like 7 feet, right? Now whether you want to remove it or not depends on what you are trying to compute. Like in general, height is not a big parameter to reject, but say you are trying to predict how many people will buy your subscription, and there are certain people in a certain pay range, and there are like two people who are earning in millions. So obviously you want to ignore those people because uh, they won't help your analysis. You want to see the average and the maximum number of people you that will buy your subscription with, while you can generate profits. So it's not like you'll keep it at the lowest price. You want to maximize it, maximize your profit while including most of the people, right? So that would be a perfect example where you might want to remove certain outliers. But it is like a controversial subject because if you remove entries, it might introduce a bias. Like certain people might use it to get a certain kind of results, and that's why you should be very careful while doing this. uh, Another way to handle missing entries is to just like fill it with different values. Like for the same example, for the area of the house, instead of ignoring it, you might want to replace it with the average size of the house in that locality. That you can replace it with average, you can replace it with median. Completely depends on you. It is a debatable topic. Certain people prefer certain methods, right? So you can and there are certain columns where you might want to replace it with zero, certain values with zero or na or something like that, right? So that just anything instead of a blank column, uh, right? So that you can run your algorithms without the program crashing, and you'll still get certain kind of results. So handling missing data one is one also something that you should look into. And there are certain predefined techniques. If you read more online, you'll find there are certain techniques you can use in certain situations. But like for unstructured data, uh, it totally depends on you, what you might want to do, right? Okay, now that was like a small overview of what you how you clean your data and what you might do in different situations, right? Now let's go for a small demo of OpenCV. OpenCV uh, is a computer vision package in Python. If you want to clean data, like how did it get from here to here, right? If you want to manipulate images, you need certain specialized packages. OpenCV is the most famous one, and I'll just give you a basic rundown of like how OpenCV works, so that you might get familiar with it. Like obviously you can, there are a lot of there's a lot of research. Computer vision is a subject on its own, and like you can just go in and read, or like keep reading. You can create a career out of it basically, because it's like it's a very vast topic, and somewhere on the lines it converges with machine learning, high end machine learning, right? So I'll just give you some of the basics. So normally what you need to do is you need to install the CV2 package. It is Python dash OpenCV. Pip install Python dash OpenCV. Once you have it, all you have to do is import CV2. I am using Colab. Colab is uh, an online notebook made available by Google. Uh, why prefer this is that it gives you a chance to use GPUs and TPUs. TPUs are basically processing units created by Google. They have specifically for ML training. Like GPUs are like general purpose. You can play games, and you can train models and everything. TPUs are specifically for training models. And right now I'm using CPU because it is free, but it has certain restrictions. You can only use it for, let's say, 12 hours at a given time, and then there is a cool off time. But if you don't have a GPU, and if you want a little fast computing, you can use Colab. Kaggle also has something similar. You can look into that as well if you want to train big models. uh, and it has certain packages installed. The reason why I didn't need to do pip install is because it has OpenCV pre-installed. You can ignore this line. This is specific to Colab, but it works similar to cv2.im show. So, okay. I'll just initiated it, and here what I'm trying to do is I'm trying to read a file that doesn't exist, so it will return a none type. So in OpenCV, every time it fails to process an image, it will return a none type, and every time it does, it will return a NumPy array. uh, I hope you are familiar with NumPy. If you're not, then it's a library for managing multi-dimensional matrices, because internally all the images are represented as matrices. Right. If you don't understand, I'll just print the image and show you what I mean by a matrix. Uh, like I am sure you know matrix, but like how it looks in NumPy. So this is a array of a it's a three-dimensional array basically, right? Okay. So I'll try to I'll just extract the shape. Channel denotes the nth dimension, and in terms of images, there is only like two for grayscale and three for uh, RGB images, or like there are other formats as well, but they all use three channels. For so RGB as is the are the primary colors. So you can extract any value, but it comes like the common convention is RGB. So red is first, green is second, and blue is third. But in OpenCV, for some reason, they are doing BGR, which is like the inverse. Uh, but you can extract the value by just pointing to to the cell in that array. So we know that it is 2000 cross 3000. So from 0 to 1999, and in height, or in the first column, and from 0 to 2999 in the second column. These are our value ranges. So I just went ahead and grabbed the value at 100 comma 100, and it is a set of three values. Blue Okay, so there is an error. Yeah, now it shows you the actual values. So these values are from 0 to
Um,
255.
I'm sorry to interrupt again, Vibhor.
Yes, Raghu.
Um, there is a blur issue. I think there was some signal issue on your end. I think it's hard to kind of read the code. You can turn off your camera. That'll be fine, and it'll help you with the bandwidth,
Oh,
and that'll be
okay.
helpful for
I
them to
can.
see the code.
Oh, mhm.
Yeah, cool.
Oh,
That's better.
and I've zoomed in so that it's not. It's a little better. Uh,
Yeah,
Surag, we are
you can
able
go ahead.
to clearly read it, right?
Yeah, I'm able to read it.
Okay. Let's just check. People, can you just in chat? Can you just comment if you are able to read it now? Not visible. Can read but still blur. Okay. Mm, quite blur. So I can try to switch to a different network. It will just take a few seconds. Yeah.
However, it's a lot better now. I can feel like it's a lot better. How about in the chat box? Oh, hi, Vibor. If you're talking, you're on mute. So
Okay. So sorry. Mm, so sorry. Okay. 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 So I'll repeat again. So in this part, I was telling about the how OpenCV returns none type if it's not able to process the image. Otherwise, it returns a NumPy ND array. NumPy is a package to handle multi-dimensional arrays. In terms of images, it will either be two-dimensional array or three-dimensional array. Here we have loaded a three-dimensional array. Uh, and you it loads certain metadata as well. So you have the if you do image.shape, you'll get the height, width, and channels. uh, uh, Here the height is from 2000, so you have cell values from 0 to 1999, and width is 3000, so you have values from 0 to 2999, and you have three channels, which means that each and every cell has three values: B, G, and R, which is the intensity of the green color, sorry, intensity of the blue color, the green color, and the red color. So each of these value in the RGB system, each of these values is 8-bit, which is basically uh, 0 to 255. So it can max go to 255, and based on these intensities, the screen will generate different colors for each cell, right? Here I've just grabbed one particular RGB set of values from the cell 1000 100 100, uh, and then here I have displayed the intensity for red, green, and blue, and the mixture will create like the color intensity for one particular pixel, right? And like that we have 2000 cross 3000 pixels. And that is why, like, if you are doing a project on images, your each data point is like a few MBs or a few KBs at least. And if you're using high end images, it is easily into some MBs. The MNIST data that I showed you was in like 32 KB or something like that, but the quality was very low. And in general, uh, image quality is one of the biggest issues for computer vision related projects, right? And here I have extracted a ROI. ROI is nothing but a small section of that particular image. So I've grabbed the values from 500 to 1500 and from 200 to 1700, and I have displayed that value. So you can see this is the uh, this is the cropped part of that from that original image, and you can see it has a very good quality. But in general, we compromise on image quality to make it more feasible to process those images. So one of the most common ways is to resize that image. Here I've converted it from 2000 3000 to 800 800, and the quality is not like degraded a lot, but now it becomes easier for us to process this image. Like 800 800 is still very big. Generally in generally people using free resources prefer 300 or 200 image size, but it depends on how much compute you have. So for resizing, it's a very simple function, cv2.resize. You pass in the image and you pass in the size that you want, right? And let let me run this again. Okay. 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 So I was talking about two channel images as well. So that is called grayscale. You can either convert it to grayscale while you are loading it. Here you can just pass in a zero, right? Or which denotes the mode in which it will read that particular image, and zero denotes for grayscale. Or you can just convert it later using the convert color function. So OpenCV has a lot of macros defined internally so that you don't have to type in random numbers. Internally, this number is mapped to zero, right? But it's easier for you to remember color underscore BGR to gray, right? And it will give you like a better interface as well, because it helps you remember that your original image was in BGR, not RGB. Like if you want to load it in RGB, that is also possible, but that doesn't give a benefit in compute or anything. So people generally leave it that way. And once it gets converted into grayscale, uh, its size also reduces. So if I do shape, it's now, instead of three channels, it has converted to one channel now, right? So we lose a lot of data here when we convert to grayscale, but we preserve the basic texture and color intensities, and it's easier to process. Okay, now obviously, you might be wondering when you looked at this image that how it got from here to here, because this seems like a crazy transformation, right? So there are certain matrix operations that you can perform, like using rapifying. There are certain operations defined within computer OpenCV. You can go through the documentation. They have a very nice documentation and very nice tutorials, right? I'll demo you some of them here, so that you have certain familiarity. So we are using the get rotation matrix 2D. So uh, all the operations you perform on images are basically multiplications or additions, right? So if you want to do any sort of transformation, you are basically doing a matrix. You need a matrix calculation, and your obviously one of the inputs to the matrix is your input image. The second one you'll have to decide based on the operation that you're trying to do. So for rotation, I'm trying to create a matrix that will uh, that we can apply on the first image. To create that, what I am using this particular function. What it takes is the center of the image. It takes the degree at which you want to rotate it, and the intensity. Now once you have that matrix prepared, you'll push it to Rapafine. Rapafine will take both these matrices and will take the output image size, the matrix that you want. Uh, if you change this value here, it will include the edges as well. But if you restrict it, it will crop the image basically. So here you can see the output is that the image got cropped where it couldn't fit, right? But it also got rotated. So the data for all these edges is lost, but you have a rotated image. Why it might be useful? Like when you are training certain models, you don't want it to detect like you don't want to detect, say you are training a face recognition model, right? uh, it clicks your image, it captures your image, it will detect, okay, this, and it maps to the right person. Now you upload an image with the face inverted and it detects a different person. That might happen, and to avoid that, you train the model on the same face but with rotated angles, right? So these are the kind of operations you apply to generalize your model so that it doesn't fail in like such common situations, right? Another thing that you might see is like how in face recognition projects, you a lot of times see that there's a box around the face, right? So computer vision not only allows us to do mathematical to do matrix multiplications on the image, certain algorithms. It also allows you to beautify your image or edit your image, like you might do in a paint software. Sorry. So this is like a function to create a rectangle on the image. These are the dimensions of the rectangle, like the first point and the last point, these 2 points. And this is the color. This is BGR, so R intensity 255. So, and the other two have intensity 0, so it will create a red box. And this is the thickness of the line. So based on how thick you want the line to be and how visible you want it to be, right? The second thing that you can do is write text, right? And your text will go here. The position of the text goes here. The position starts from here. So in computer vision in general, you have your 0 0 axis at top left. So it starts from here, and everything you define goes from top left to right bottom. So if I am defining something, it will start from here, and if there is an endpoint, it will end here. For demo, it started from this point, but there is no endpoint. Why is that? Because we have other parameters to decide what the how much space your text will take. This is like the font style, this is the font size, which will basically decide how much space the word will take. This is again the color. Here the blue region has the maximum intensity, so the text is in blue color. And this is the thickness of the lines. It can be like a very big text, but if the thickness of the lines is not enough, it might still not be visible. So these are all the parameters that you can use while adding text to your images. And like now I hope you can relate it to all the online image projects that you see. These are all the refinement details that they add to their project once the model is trained and once the output is there. But they're like simple functions that you can use to edit your image. Right now, another very popular algorithm is Gaussian blur. Right, why you might want to blur a certain image. Okay, so say you have this parrot, right, and you want to extract it and like ignore the background. Right now, when you run certain detection algorithms, it detects the background as well. Right, but you know that the object in the foreground has more texture, has more data in it. So you'll just do a Gaussian blur and then run your algorithms. That will give you a more refined output. I'll show you what I mean by like data. So here we'll run a canny edge detection. Canny edge detection is just a edge detection algorithm. It is one of the most popular ones. Uh, you can go through the calculation, or we can discuss it in the next session. But basically what it does is it will capture all the turns and edges, and everywhere there is a little bit of texture. Right, so this is the parrot. Here you can see it has ignored all the background. Right, but in case we got little bit of texture here or there, we could have used Gaussian blur and then run canny edge to just ignore it. Now remember, all these edge detection and thresholding algorithms require grayscale images. They don't work on RGB images. Okay, now another algorithm is threshold detection. Right, so here if I run a threshold detection, you can see it does capture a little bit of background. And this is because the threshold algorithm we are using takes in the min and max. Right, now here I've set it to 100, so I can also set it to 200, but it will only capture more data, and that would be difficult for us. Right, once you are done with thresholding, you can refine these even further, because you can see there are certain missing spots. And if you want like a single solid image, you'll have to process it a little more. The most common ones are erosion and dilation. What does that mean? Erosion and dilation are again matrix operations. It will give you a certain output like this. This is like this one is more has is more solid, so to say. Right, if you can see the difference. And what happened here is uh, Erode ran a 3 by 3 matrix, and it basically counted how many cells within that matrix had a high intensity. So in grayscale also you'll have from 0 to 255. Right, but all these but in general we prefer to have only two values, either 0 or 255 or 0 or 1. Right, so for that we do some more processing. uh, and Erode is the perfect function for that. It will run a 3 cross 3 matrix. It will see how many of the pixels have a have certain like value above zero, and it will, if say 5 out of 9 columns have zero, it will assign it a zero, and it will go through the whole image, and it will do the same process, and that way you get this image out of that image, right? The opposite is dilation. Now see, you have certain blocks filled here, gaps here. If you run dilation here, it will fill those particular blocks, and then you won't have gaps within this particular blob. It is a little tricky. I would understand if you like are getting a little confused, because this does require a little bit of more experimentation on your own, and a little bit of uh, going through more research. But yes, these are certain operation for now. What you have to remember is that these are certain operations that are very common for image manipulation. And right, okay. Okay, I think we should give a little rest to the image, and I'll come to text. I am going to discuss some of the common algorithms for text manipulation. So, one of the most common ones you will hear is bag of words. So, what that is basically, it is a table of so f- it has two steps. First step is that you create a table from the dictionary that you have. Dictionary is basically the set of all recognizable words that you have collected. Okay, you collect the words, you assign it an id. Okay, and like here you can see I has been assigned a value of 33, and this has been assigned a value of 88. Now whenever a sentence comes in, you just create a simple table that will have that particular word and the idea associated with it. What that does is it gives all those words an integer value which you can process on. So that is one of the biggest advantages we get from this particular algorithm. It has a numerical representation, and now it is possible for you to apply a lot of algorithms on that particular this particular sentence, right? But again, data cleaning becomes a big issue here, because a capital I or a small I shouldn't have a different id. Then there are apostrophes, and then there are question marks, and there are certain words like armrest which might have a dash between them, it might have a space between them, it might have no space between them, but they're all the same words, right? So you can create a bag of words, but again, one even before you start processing a text corpus, you have to do a little bit of data cleaning, which is called tokenization. So you, when you go through articles, you might hear the word tokenization a lot. It is nothing but data cleaning for text. Okay, now one of the most popular algorithms uh, is term frequency inverse document frequency. uh, Generally, once you understand this, you go to high level machine learning algorithms like ngram. So this is the most complicated statistical process that you will come across in text, and this is also used in a lot of text related natural language understanding related models. So let's go through a small example. So you have these two sentences: the car is driven on the road, the truck is driven on the highway, right? So this is called a corpus, and sentence one is document, and sentence two are documents. This is a typical terminology for NLP, right? So when I say that I'm going to calculate the term frequency, what I'm doing is I'm calculating how many times a certain word was repeated from within that document or that sentence, right? So here you have 1 by 7 for these words, and for truck you have 0, and highway you have 0 for the for sentence 1, right? Similarly, for sentence you 2, you have a similar column. Now which is evident from this particular formula, right? uh, The second is IDF, which is uh, which so basically what we are doing is, now instead of looking at the sentences, we are looking at the whole corpus and the number of times the word has repeated in that corpus versus the number of times the word has repeated within that document. So the has been repeated twice in the whole corpus, right? So it gets 2 by 2, and like car has been repeated once, but the total number of corpuses is 2, so 2 by 1, and is present in both the corpuses, so 2 cross 2. So all the common words will get a 2 cross 2, and all the unique words like car and truck will get a 2 by 1. And then we multiply this number with our term frequency, and we'll get the term frequency for each sentence, which is basically a very complicated way to say how many times does the word car come up in your corpus, right? Instead of saying like 35,000 times out of like 1 lakh, you can use this number, which is easily processable by algorithms as well, and it gives you a better perspective. Because words like the and is would be very common, right? So there would be a bias with these words. Okay, okay. Now let's go to Keras demo. So there are different models, like scikit-learn, that will give you some basic ML related algorithms like regression and uh, random forest, right? And we'll go into all those details as well. But for now, I wanted you to get a feel of how you can uh, like train your own models, right? And especially image related models, since they are the most difficult ones as far as compute complexity is concerned, right? And we are going to use the Keras package for that. Uh, so, so the Keras package is a little unique in the sense that it was uh, it was created as a wrapper for TensorFlow package, right? And because so Google released TensorFlow for all its machine learning processes, and then it became very difficult to like debug TensorFlow, right? So the Keras project was started. It was a wrapper over TensorFlow, and in the backend, it could use Cafe and other packages as well. But Cafe and all the other packages were taking a backseat. Right now, the most popular packages are like uh, TensorFlow, Keras, PyTorch, and Theano is also a little popular, but yeah, the Keras and PyTorch, I guess, are the most famous ones right now. So what happened is that in TensorFlow 2.0, the TensorFlow team tried to absorb the whole Keras package, and that is why you'll see that I'm importing Keras from TensorFlow. So in Keras 1, you could have just imported Keras, import Keras. In Keras 2 and above, you do from TensorFlow import Keras. And the Keras project has certain popular packages already installed for you, like you can see here. I am downloading the MNIST package. I don't have to download it from the internet. The Keras package already has that, and it has certain functions that we saw in OpenCV defined in it. So here you are taking the train and the test sets. So before we go to the code, let me give you a brief on what this train and test philosophy is. So whenever you are training a model, you want to have a big data set you can train on. But to evaluate how the model is doing, you'll need a reference point, right? And that reference point is the test set. N- uh, and going one step further, there is a validation set as well, right? So the basic concept is that you keep your test and validation sets similar. Your training set can have anything that you want, right? uh, and you start training, and then you pit it against your test set to see how accurate it is while training, and then as a sanity check you run it against your validation set, because it might happen that the algorithm started learning the information about the test set, right? And it started copying, like if you get this response, just give this. So these are the kind of errors that happen a lot in machine learning algorithms. It is this is called overfitting. Overfitting is nothing but the algorithm mugging up the answers, right? And why that creates a problem is that in real life situations, the environment can be very dynamic and anything can happen. So if the algorithm has mugged up answers for certain situations, it might not do well in in public situations. So because of that, we take a third set called validation set, and we test against it to see whether our model is overfitting or not. The reverse case would be underfitting, where the model is not able to perform well within the training set itself. In that case, you just like you just improve your model. You take a more complicated model, like you go from regression to random forest to something in keras, like step by step you just keep increasing the complexity, right? Here we are not going to look into overfitting and all right now, uh, because that has a lot of its own techniques that we'll get into in a separate section. But the simple thing is that we are loading it, and now we are reshaping it. So reshape is similar to the resize in OpenCV. Keras has a lot of its own operations predefined. It does support OpenCV, but for the most part, you don't have to go outside Keras. It's a very big project, and it will have most of the things that you need. Right here, first thing you'll observe is it is converting it into a 28 cross 28 cross 1 matrix. So one is the channel, right? So basically what it's doing is it's converting it from a 3D matrix to a 1D matrix. Because as you might have seen here, uh, it is all black and white, right? So you don't need three channels to depict black and white, especially when it's taking up so much space and compute. And then what it's doing is it is converting it into float and dividing it by 255. So now all your value range is from 0 to 1. So that does have a certain benefits when you are doing mathematical operations. So a lot of times people prefer to normalize the values to 0 to 1, right? And then what it's doing is it's taking the output and converting it into categorical data. So you have two types of data. One is the numbers and one is the categories. Numbers can be the area of the house, like 550 square feet or something like that. And category can be gender, like male or female. There can be only two categories in certain forms, right? Depending on how you create that form, they can be three, they can be two, they can be multiple. But the main point is that you have to define the number of categories that you have. Like in this case, from 0 to 9 you have 10 categories. Now this has internally converted it to Keras compatible categorical values, right? It might have 0, 1, 2, 3 on its own in integer form, but now it has. But for fast processing, Keras defined its own uh, set of values, and you'll find that a lot of packages do this. They try to define like they try to define their own functions even for simplest of operations so that they can optimize the compute, because runtime is one of the like major topics that you'll come across. Here what it's doing is it's creating a simple sequential model. First is the convolution layer. Like I said, it's these are all matrix multiplications. So just like we created matrix for rotation, here we are creating a matrix for 2D, multiplying the original data with a convolution matrix. It has a kernel size of 3. What it means is that the convolution matrix will have a size 3, and it will apply that convolution operation uh, in a section of 3 cross 3 across that image. So the image can be 600 cross 600, but the convolution operation will be applied on on say 3 cross 3 matrices, subsections of that particular image, right? And it will be applied 32 times. So here you go into n dimensional matrix, the size of the image will reduce uh, in terms of length and breadth, but the number of channels will increase to 32. Here is the activation function. Activation function is used to get the final value after, it's basically used for thresholding and get the final value after the convolution operation. And here is the input size of the image. Here you can see we already uh, converted it to 28 cross 28. We are just defining it for this particular function, right? Then once that is done, we are doing a max pool layer with a kernel size of 2 cross 2. Right. And what max pooling does is just like erosion. What it will do is it will run a 2 cross 2 matrix, and within that matrix, say the values are 1, 45, 30, and 100. So it will take 100 and it will put it into the new matrix. That's why it's called max pooling. It will take a small section defined by the pool size, say 2 cross 2. It will get the maximum value, and once it gets the maximum value, it will put it in the uh, new section. So here you might observe that we keep reducing the size of the matrix that we entered. Now the size is decreasing, but through this process what we are doing is we are trying to grab the most important features from that image, because we don't need the whole image, we only need the relevant sections that will help us achieve our task. Say we want to detect what animal it is in that particular image, like the parrot image, right? So it will try to detect whether there is an animal in that image, and if it is, what type of animal. So for that you don't need the whole image, you can ignore certain sections, and that's what it's trying to learn through these operations. So now once these are the only two operations that I'm applying. Once that is done, we are basically flattening it. We are converting it from, like, say 40 cross 40 cross 32 to a single array, and then feeding it to a dense layer. So dense layer is uh, so the first layer is 128. It is nothing, it's like multiple nodes with the ReLU activation function. So I'll show you what the ReLU activation function is. It is nothing but a function that represents this. So all the values before 0 will become 0, and all the values after 0 will be preserved, right? So this is all the activation function is doing. It is acting as a cutoff for the first layer. Now in the second layer, what we are doing is we are feeding each of the 128 values to each of the 10 value nodes, right? And it's implementing the softmax function here. So softmax is something like this. It has a curve, it has a certain threshold, and everything after this. So the main aim of softmax is that this particular curve should be small, so that it acts as a threshold gate. So every value after 6 here will have a value of 1, and every value of minus 6 will have -1. And we try to keep the softmax curve small so that very few values will come under this section. So again, it is doing a threshold for these 128 values, right? But it is ultimately trying to come up with a single answer, whether it is 0, 1, 2, 3, 4, 5, or like 9, right? So the convolution 2D operation and the max pooling are very common for images. The dense layer concept is generic for all the machine deep learning models, right? And this is like a standard set of function. We generally call it the head of the model, and I'll show you how it actually looks. So here you can do model.summary to see how your model is getting processed. So you see, and you can even see the parameters here. So a lot of times you'll see that these big models like Palm 540 and all are defined by the number of parameters it has. So Palm 540 has 540 billion parameters, right? Here we have like uh, 693,962 parameters. But as you do bigger projects, you'll see that these parameters will go into uh, billions and billions of values. And it's also giving you the size of your model. Right now it's 2 MB. Generally, when you get to that size, you'll get a few hundred GBs of models, right? And this is like a very nice way to see how what the flow of the model is, because this is like a linear model, but it can get very complicated very fast, because you can have multiple heads, you can have uh, multiple models converging. You can do a lot with it. This is just a simple sequential model that that I chose because it has all the uh, relevant details. It has the conv 2D, it has the max pooling, it has the dense layer. You'll get average pooling as well, which is a little more advanced function. Average global pooling is a little tricky to implement, and it came out just a few years back. And there are other functions as well that we might go into detail later. So once your structure is ready, now you need to feed these images into the structure so that it can start calculating these values. Right now, this matrix is filled with random values. It doesn't have anything uh, significant, and it can't predict anything. But we'll compile it. We have selected cross entropy formula for calculating the loss. So every time you are training, it's comparing the image to the output, trying to compare it, right? So it's so for that particular comparison, it's using a loss function. Here we have Keras has a predefined categorical cross entropy. You can go to the documentation and see the exact formula. uh, why I insist on looking into the documentation is because with these mathematical formulas, there can be multiple ways they are defined. And you shouldn't assume that a particular library is using a particular formula. You should always go to the documentation and check what particular formula it's using, right? And what are the caveats and what it accepts. Optimizer is Adam delta. So optimizer is basically used to correct the parameter values. So once the loss is defined, say we have a very big loss, say 100 or something like that, it will feed that back to the network. And the network will use the optimizer function to make corrections into its values. So the random numbers will start changing little by little, and they'll start converging to a meaningful number that will help us get to the right value. And the matrix that we are using here is accuracy. So the loss and the optimization are happening here for accuracy. There are other matrices as well, like there is recall, there is precision, there is F1. So which concentrate on different aspects, like how many values did we say, like how many numbers did we say were five but they were not, or how many numbers did we say were five and they were actually five, and all sorts of these different combinations will result in different matrices. Here I've used the simplest of the matrix, which is accuracy, which is basically we said it would be 5 and it was 5, we said it would be 9 and it was 9, like that. Okay, and batch size is 128, so at a given time it will process 128 images and it will do that 12 times. So epoch is nothing but the loop cycle, or the number of times the loop will run, right? And we do a model dot once the model is compiled, it has the loss function and the optimization and the matrix. We'll do a model dot fit. So this is a common terminology for all the machine learning models. Whenever you do a model dot fit, it means that you're trying to train the model, and it will start the loop, it will start feeding the images, it will start doing the calculations, and it will try to come up with a with certain set of parameters that are close to the actual truth. So once the training is done, this particular model that I showed you here, which right now has random values, will have certain values that will certain significant values that we call our parameters, or uh, the actual model itself. So these are called the model values, and these are the hyper parameters. Basically batch size is a hyper parameter. So what is a hyper parameter? So you have a model ready, right? So you have decided that okay, this model structure works best for us and we are not going to change it. Okay, so once you decide that you're not going to change it, there are still a lot of changes you can make in it and how you're training it, like the batch size or the learning rate, which we have not defined here, which is a little advanced topic for this particular session. We'll cover it in the next session, right? And then there is number of epochs. You can make it 10, you can make it 100, you can run the loop for as long as you want, right? So these are the parameters beyond the model. So you have certain parameters here and then you have certain parameters here. So to distinguish between these two parameters, we gave this set of parameters the name of hyperparameters. And uh, based on these hyperparameters, you'll get these particular parameters. And the ideal response is that if you have a fixed set of hyperparameters, you should always get the same set of parameters. But that might not be true, because internally it is doing some randomization as well. So that is why we are running it multiple times. The same, why we are running the same thing again and again and again, because internally we are trying to randomize it and see if it will still give the same result, so that it doesn't mug up, it doesn't overfit, right? So this is also one of the things you should be careful of, because certain libraries and certain functions might have randomization within them, and you'll obviously have to go through the documentation and see. And if you don't want that certain randomization, you'll have to turn it off. And if it is not, if you can't turn it off, you'll have to deal with it in other ways. But the most common way is that you run it multiple times, like 10 times or 20 times with certain epochs. So that is the overview of how the training API works, right? And once you have that, you use model.evaluate and you feed the test data to see how it was able to whether it was able to learn what we wanted or not, right? So let me run this, and while it okay, okay, I think I missed running certain code. Let me run it again. Yeah, so now it's running. Loss is 2.2, accuracy is only 13% right now, right? It will take some time, even though it is like, you see, the image size is 28 cross 28, right? It will still take some time to run it, because the number of computes that is happening internally. Okay, while it runs, any questions so far? Like, you want me to revisit certain sections?
So one of the question that I got is I saw a lot of is that they can try that code on their PC itself. That will be
Yeah. So this
uh,
collab is a Google link. I can make it public and share it with everyone, and they can run this whole thing on their own, and like try to train the model on their own. They can like, that is available. But any conceptual thing, because I think the most difficult thing here is the matrix multiplication, and like in next session I can have certain visualizations so that it is easy, because in next session we'll deep dive into how these algorithms work. So this is like the how the functions work, how the APIs work. If you know this, you can train any model. But if you want to train it in a proper way, you'll have to know what's going inside this particular fit function, right? And that's a little advanced, and we'll like go through that. But if there's a particular top thing that you didn't understand within this presentation, I'd be happy to go over it again.
okay. So if you guys
I
having any question, you can drop it in the chat box. Unfortunately, everybody here doesn't have the voice or the mic access, so you can drop it
mm,
the question in the
okay, so
chat box.
John asked something. Okay, so OpenCV, the OpenCV demo file that I showed, no, face recognition can't be done using that code. But can OpenCV do face recognition? Yes. So all these projects are continuously expanding, and uh, what they have done is they have defined their own internal functions for everything. So you can, I chose Keras, but you can train models in OpenCV as well, and you can do a face recognition project in OpenCV. Right. So not with the demo file, but yes, OpenCV can do face recognition. And as a matter of fact, you don't even need like a lot of complicated algorithms. There's a har cascade in OpenCV, which is like a Gaussian, which runs just like the Gaussian filter or any other function. It takes very less compute, and it will detect faces for you. So that's why you can train a model to recognize faces, or you can just like do choose certain other algorithms for certain other packages. But I would recommend that you go deeper into OpenCV and NLTK, which is for Python package for natural language processing. I hope that more than answers your question. Okay, everyone is asking for the G Drive link. Don't worry, I'll share it after the session. I didn't want to share it before the session, because then uh, you all would have gotten distracted. Thomas is saying we need to learn the basics and how to train. So, yeah, this notebook that I'll share has the basics. It has the basics for image manipulation and model training. And I think I have more than simplified all these algorithms and the whole process that goes into like training the model. When in next section, how batch size affects accuracy? Okay, batch, how batch, when is next session? So Surag, I guess the next session is next week, right? Same time.
Yes, next
Yeah,
week Saturday, same time.
yeah, same time. And how batch size affects accuracy? So biggest difficulty with batch size is that it depends on how many images you can feed at a time in the in RAM. But batch size again is like changing the batch size is again a topic of research. There are some researchers who have used a batch size of 1, and they're like stochastic uh, batch size, something like that. You can search that, and they've gotten good results. Some researchers have used the whole data set as the batch size. Like if they have 1,000 images, they have used 1,000 as the batch size, and they have also got good results in certain situations. So it depends on the project that you're doing, but I'd recommend you to go through some of this research, because there is no like one answer. It totally depends on your project. Activation function is used like softmax. Okay, confusion. What? Okay, what activation function is used? So, uh, so I'll tell you about the general convention. I won't confuse you a lot. So, the general convention is like for NLP related projects, we use TANX because that gives a better result. For computer vision and say certain uh, categorical certain regression data, we use leaky relu, right, for internally training it, and we use softmax for prediction purposes, softmax or sigmoid. Because like you see, I've used the same convention here as well. I have initiated everything with relu, but in the last layer I've used softmax because softmax works better for prediction. The difference between softmax and uh, sigmoid is that sigmoid uh, will give you a overall percentage. Like if you have three uh, categories, it will say okay, first category is 30%, second is 30%, fourth is 40%. You can add it up and it will come out to be 1, which is 100%. But with softmax, each and every category get its own percentage value. So 0 can be 1 to 100%, and 5 can also be 1 to 100%, right? So that but in general, softmax and sigmoid are used in the last layer of prediction. This is the general convention. Why this is the general convention is, again, this has all been derived from different research papers that have been coming in. What I'll try to do is I'll try to give provide the links to these research papers as well, like even for the batch size one and for this one, so that you don't have to go through the whole thing. You can just go through the abstract and the conclusions, and if you have that mathematical aptitude, you can go through the whole thing. But you'll understand why these conventions are set because of this. But for now, even if you remember that, okay, TANX is for NLP projects, ReLU is for all the internal layers, and Softmax is for the last layer, you'll be good. And TANX, I think we didn't discuss, but yeah, good that you are aware of it. Yeah, you can reach out to me. You can just Google me, Vibhor Jain, or should I like? Uh, I'll what I'll do is I'll share my LinkedIn ID with Surag, and he can like share it with all of you. That works, right, Surag? Hello, Surag, you're on mute.
Yes, we both. I think I missed something.
Okay, so someone was asking how they can connect with me. So I'll share. Can you share my LinkedIn ID with everyone?
It's
Like
um or
after after the
where do
session,
you
do they get a mail or something, or should I just post it in the chat box?
uh
I'm not logged in. Okay, just
can post it in the chat. Okay.
share LinkedIn. Bad SEO. Okay, my name That's weird. My LinkedIn profile used to be on top, but now it's not. Uh, okay, just give me a minute. I'll share that. And there were other questions, technical questions. Okay, for Thomas, softmax for last layer of prediction, specifically last layer. Okay. What does max pooling mean? Okay, so I'll revisit this. So say you have the max pooling function and you have defined the pool size as 2 cross 2, right? And your image size is 800 cross 800. What it will do is it will go across the 800 cross 800 image in a set of 2 cross 2 matrix, right? It will read those values. It will see, okay, 1, 2, 3, 4. Okay, it will see the maximum value that is there, which is 4. It will capture it and save it in a new matrix. That way it will then move to the next set of 2 cross 2 matrix, and your image size will become from 800 cross 800 to 400 cross 400, and it will include all the values, all the max values for of the previous matrix. That is max pooling. And when you use it, so generally max pooling is used after the convolution operation, after one or two. That is the convention, because like some researchers prefer it after two convolution layers, some prefer it after every convolution layer. And that is, again, depending on what research paper you read, you might follow different conventions. But yeah, in general, we do max pooling so that it doesn't the conv layer doesn't overfit, basically, and to reduce the size, to extract the main feature points from that convoluted matrix. So it can have two reasons. Okay, everyone is asking for the G Drive link. It will be shared later. uh, okay. Hmm. Let me stop sharing my screen. Let me see if I can get LinkedIn ID. Yeah. uh, yeah, this one, Sumit. I have also pinged you the link. Okay, some people are sharing random collab links. Please don't do that. Okay. Yeah, and I don't see any other questions, Surag. Okay. Okay. Okay, Joseph. I don't think this is the right link. Please, people don't click on random links. You might get hacked. Okay, this link is not working. Okay. You can just search Vibhor Jain on LinkedIn. That should work. I'm not sure why. What happened to my LinkedIn? Hmm. Okay, it's Vibhor. Let me try this. Uh, it's linkedin.com/in/Vibhor. VWBHOR. Sarag, you there?
Yes. So the attendance link has shared in the chat box. You should be able to. This is the same link, but it will have a update, and if you should be able to edit your response, and you will get the day to attendance there. Hi, Vibor. I think you are working on the link, right? Or we can take the time, and then
No,
if
no, I
it's
have
taking
shared the
longer,
link.
then.
I have shared the link, and someone
Uh-huh.
said that it's working. It's or like yeah. Or if you want, you can just type it linkedin.com/in/Vibhor, VWBHOR, or I can post it again for your convenience. Yeah, so yeah, I'm done.
Okay, so I think we don't have any more questions. We both have made the link accessible for or the code accessible for everybody. So please do check it. And so yeah, so with that we are done with the day two for the study jam. I hope most of your queries were answered, and we'll try to bring up more resources in the community. So be sure to be in the community to get any update. We'll share some of the resources that will help you learn a little bit more further by the time we have the next advanced session on ML. So I think you should be prepared for it. So you don't feel like you are lost in the when we talk about advanced stuff. So yeah, that's it. I would like to thank Vibho for taking his time to explain everything, and thank you for that. And thank you everyone for joining and taking your time to um, participate in the session. We really hope that you will continue it and put effort to learn it, and continue with us for the next 2 more days, which will be from next 2 Saturdays. So we'll be updating you about all the sessions in the community and over the email that you have registered. So with that, we are concluding the day 2, and you all can resume or any other task that you have, and have a great Saturday. See you in the next session. Thank you, Vibhor, and thank you, everyone.
Thank you. Bye bye.
Bye bye. With that, we have concluded today's session, and I'll be ending the session, and you all will be removed from the session. And if there is any more query, um, please to drop it in the chat box, or you can join our community to post your queries. So let me share the link to both of our community. So I'm sharing it in the chat box. Be sure to check it. It's a must join community for getting the update, and update first. We might have a delay in the email, so be sure to be there. And the attendance link also been shared in the chat box. If you're not able to see it, let me share it one more time. Um, this is the same link, but the form is updated, which means you might get the edit button when you if you're already filled it. So you can click on the edit, and it will show a new section which you can where you can update your day 2. Okay. Um, has shared the community link one more time, the Discord or WhatsApp. Please to join there. And with that, we are done here. I think we are earlier than the scheduled time, which is 2 hour. And I think there were some question about why this is taking too long, but I think this is not enough time to cover all the topic, and actually be able to be able to conduct a session, or be able to do what we showed in the session. So it only if you already have the understanding, then you'll be able to understand things better. But if you're completely new, this is not enough time. So be sure to put in effort, and mm, in trying out the resources and all the code that we have shared, to make sure that you understand everything. uh, Samuel, there is as I mentioned from the beginning, that there is no day by day certificate. There will be only 4 days of certificate. So it's after the 4 day you will get certificate. You need to put the attendance in order for you to get it. So I'm not sure. A yes button is not working. Uh, Sami, I think it works. I think somebody was asking they're not able to click on yes, but it definitely works. I just tried it with another ID. It definitely works. So if you didn't watch the day 1, once you fill out that form, you will get the day 1 recording, and we'll update the day 2 as well once you fill it. So Basically, you can click on that link and you will directly go to the YouTube link where you can see the day one. And after that, you can fill the form again with that you watched the recording, and then you can go on with it with day two and day three. So yeah, that's it. So the next day three, Chandler, it will be on next Saturday. It will be next two will be on Saturday, same time as today. Okay. Okay. That's all the questions that I have answered. Thank you and have a great Saturday. I'm gonna be updating if there is any other update related to the session, and we'll have a lot more webinars and training coming up in the community. So be sure to check the community. Okay, with that we are done here, and appreciate the time, and see you in the next session. Thank you.